Shrikant Chennai. Uh, he will be talking on navigating the ethical, legal, and technological frontiers using AI, how things are going to happen. He is specialized in sports field, and to chair the session, I would like to invite Professor Naveen Kumar to chair the session of this keynote address. Professor Naveen Kumar is a senior professor and chairman in the Department of Electronics. His area of research is semiconductor electronics, nanosensors. He has many publications there and has been guiding PhD students into that area. Some of his students have gone to UK. He started his career at University of Mysore as an assistant professor there, and then he has come to Mangalore University as a professor, and now he is my colleague as a senior professor. I welcome Professor Naveen Kumar to this program, and I request him to chair the session. I request Mr. Narayan Prakash to hand over a rose and welcome Professor Naveen Kumar. Over to you, sir.
Thank you, Professor Khan. Good afternoon. Already too late. It is an honor to welcome Shrikant Chennai. He's a great, he's a CEO at CoachBuddy, and he's a depth startup focused on developing RL-based real-time autonomous and playing partner for Request Sports. Has close to 30 years of in-depth experience across the breadth of the software spectrum, providing guidance, architecture, and implementation. It's the most work at the CoachBuddy combines advanced computer vision algorithms, optimization techniques, and physics-based modeling to create player-specific models, driving AI and big data on the edge. Is passionate about the novel application of AI algorithm to sports domain. Is the recipient of Badminton World Federation 2024 and research grant for innovation in badminton sports science. More recently is working on the optimization game strategies in request sports using a federated reinforcement learning. It is a great honor to welcome you to this keynote address, sir. Please, sir, take your decision.
Shall we start? Okay. Hi everybody, good afternoon. Thanks for, although it's delayed, listening to me. I will keep it short. I want to kind of set the tone for how responsible AI is. All said and done, finally responsible AI is the headache of the industry. Academia is never responsible for responsible AI. It is we who bear the brunt. We are at the receiving end of all the regulatory compliance issues. So I think it makes sense I talk about responsible AI because we are at the receiving end here. So I'll start with the intro, setting a tone of questions. What kind of models do we want to look and what kind of problems that we want to address? And I, for one, am more interested in the technology side of it, how to address the practical problems in industry under various pillars of responsible AI, naming privacy, bias, fairness, and more than that, explainability and causality. So here we are having a conference on responsible AI. Itself is a vindication that responsible AI or the AI has matured, has reached a place where we can talk about taming the horse and making sure that the decisions taken by it are not affecting the society in a bad ways. We also would like to dimensions of RAI, right? So dimensions would include, you would already know it, so but privacy, fairness, bias, explainability, transparency, robustness, and most of all governance. But there are some aspects as we here would be less interested. I guess everybody is from a STEM background here. Anybody from non-STEM? No, right? So here we have a certain bias towards talking about technology. And we are trying to eliminate the bias in responsible AI. Ironic, right? We have a bias already built in, but we are talking of bias in AI. This brings to me a question of bias is inherent in human beings. I mean, that's how we have evolved, right? For all the neurologists modeling of our brain, What is a brain? It's a giant Bayesian engine. You all know what a Bayes theorem is, right? P of A given B is equal to P of B given A into P of A. I lay out the denominator there. But what is P of A given B? It's a posterior probability. You're going to look at what's going to happen later. But it's dependent on P of B given A, meaning what am I really seeing out there? So it's a product of what am I seeing and P of A, which is my already inherent bias. So when the humans have bias, the models that they design, the data that they collect are going to have bias, and bias can never be removed from AI model. It can be mitigated, but it can never be removed. That is the first point I want to make about responsible AI. And towards bias and fairness analysis, I look at a couple of models. I don't want it to be more like a chat monologue from my side. I would raise some questions, make you think about it. So let's pick one simple model like a rental payment prediction, right? Or a home mortgage. How would such a model work? So you're going to have some data collected from the field, possibly also includes the color, the race, the religion, caste, gender as the features. I mean, regardless of whether you're going to use it or not, there is no prohibition on collecting it as far as the customer is opting for it. So we'll collect it nonetheless. So once it is collected, what happens? Can you use it in your model? Well, no. There are certain fields where we cannot use this. Expressly, it is prohibited by law. Not in India. I mean, Indian laws are kind of gray area in this. But since we cater to mostly US and European customers, our area is Fair Housing Act, California Acts, and GDPR in Europe and so on. So these are the areas that we have to adhere to even though we work from India. So collecting this is fine as long as the customer has opted in, but we cannot use them. Imagine, let us say hypothetically, somehow the race or the color is going to be a good indicator for me to predict whether somebody is going to default on their home loan. It's a good predictor, let us say. But can I still use it? No. Even if it increases the prediction accuracy of my model, I cannot use it. So here we are facing problem in the business, right? On one hand, we want to increase the accuracy of our models, but the goals set by the government are at loggerheads with what we are trying to do. Even if it shows statistical correlation, that's not allowed. And I just want to ponder a bit on why it is not allowed. Why from a regulatory perspective and why from an ethical perspective as well. So why, right? It's unfair to the individuals who are paying rent on time. Let us say somebody of some color, right? Maybe their community has a history of not paying their rent or defaulting on their home loan, but there are going to be people who are going to pay. And we cannot penalize individuals based on group trends. That is statistical discrimination and systemic exclusion. This is a big point because you already have certain stereotypes in the market, stereotypes in the community. Now your AI model is bringing about this exclusion of those people, which is further reinforcing and increasing this. As a society, it is something that should be shunned, and I guess the regulations are really helping there. Now, yes, we talked about the fairness to the end users who are taking a loan, but is this fair to the business owners, right? I mean, we are at the other end, so I'm asking this question. As a business owner, if I am giving out loans and I know that, from a certain community, people are going to default more, and my data can be rooted in accurate historical data, is it fair to me? Is it fair to a business? Because I might face some genuine financial risks, foreclosures, and risks due to late payments also. But unfortunately or fortunately, governments and regulators prioritize protecting individuals from systemic discrimination. Vulnerable groups have to be protected. So instead, what do we do? Do we have one side that we can pick on? I don't know what side you will pick on. If you are somebody at the receiving end, maybe you want a loan, you don't want to be discriminated. Maybe you are an activist, you don't want to be discriminated. Maybe you are in the academia or somebody else, you really don't care. But what about the other side person, right? He will say, if this is going to affect my bottom line, then I don't like this regulatory practice, right? In Kannada we have a saying, Vivekananda huttbeku adre namma maneyalli alla. So that's exactly that. So I'm getting into these ethical issues beyond the legal things. What affects us personally affects our bottom lines. So if I can't use color, if I can't use race, gender, all this stuff, what am I going to use? Well, people figured out, okay, there are some pseudo alternatives, like I could use socioeconomic status and their current address, the neighborhoods in which they live. This can be used. You see, this is a tricky thing, right? Because finally the neighborhood that you live, especially in Europe and US, can indicate what socio-economic status you are and ultimately also hint at what race and color you are. So this is like you have a chape kelag hodre regulation, you are going rangoli, under the rangoli. Exactly that from Kannada perspective. Pardon all those who don't know Kannada, that's a pun on how things get done. So we have to look at real alternatives, right? So real alternatives are credit score, employment status, debt to income ratio, income stability. Are they sticking to a job and have the capability to pay the EMI? I feel like these are good replacements for color, race, gender, because one, they do not depend on the group trends, and they actually work on the individual's capability, individual's merit on paying back the loan. And this brings me to a question finally. Will the bias anyway go away? No. I think even in the society, the bias will not go away. And AI models are only a reflection of the society. So these artificially induced constraints help us to mitigate the biases in our models forcefully. But until those biases don't go away from society, the models will not be truly free from bias. We have to live with that. Now let me bring to the another question. Is age allowed in any of the AI models? What's your take? Who says age can be allowed? Who says age cannot be allowed? Just raise of hands. Age can be allowed? Can be allowed? All right. How about marital status? Should be allowed? I'll tell you one thing. We are in software, right? So the recruiting problem comes in. So let's say we pay 20 lakhs to people, correct? And then we hire somebody, some woman that is married. You know the Indian government rules, we have to pay the maternity leave 6 months. So that's 10 lakh there, right there, out of the 20 lakh, the payment we have to do. As a small company, would that bring in bias? Correct? That's a bias, right? It may not work for the small company, but big companies, MNCs do give that. But remember, in the long run, more and more smaller companies will be the employment generators, not the bigger ones. So we are going to see this problem big in future. That is something to watch out. And most of the hirings are done not through AI, but through oral communication, stuff like that, right? So there is always plausible deniability to escape from the law. So even by eliminating the bias and things from AI models, things will not change fully. That's my point. How about age? This is my own example. I worked in the US for 15 years. I came back to India. I was like closing in on 40. In US, the system is different. You could pursue your technical line and keep going and going, no problem. Your project manager or a team lead is just a role. It's not your salary and designation thing. Whereas in India, primarily service-oriented companies, they're like, okay, you are a contributor, analyst, software, senior software, lead, project manager, program manager. The moment they cross the lead, they are working in Excel for the rest of their lives. And then they will be the ones who control the technical work. So when I came back to India, it was a wake-up call. If I went to the technical line, I will be at a severely disadvantaged thing. So was age a discriminatory thing? Yes. But if the more and more AI models are going to make recruiting decisions, these biases will come in. Now let me ask you something about Insurance. Insurance premium calculations. Is age a discriminatory thing? I mean, AI models use the insurance calculation these days. Is age bad there? I mean, the whole actuarial science is based on age, right? If we don't use age, all the insurance companies will go bankrupt. And it will not impact just one or two, but all of us. Why? LIC is the largest institutional investor in the market. Imagine if LIC collapses, the market is going to fall 30%. And all of the people who have invested in the market, it will affect them. So some things are allowed based on the context. This is my point here. Some things which look bad in certain area are the right things to use when we are developing AI models. And now I'll come to another area in medical. So let's talk about ICUs, right? We have ICUs and patients and doctor. Sometimes what happens, certain race, people of certain race or some community are genetically predisposed to certain diseases. So if you are going to use ICU, AI models in ICU, like we did in Manipal, then we can treat the people better, faster, where time is of the essence in the ICU if we know a lot of personal traits of that person, correct? So there is absolutely no doubt that using the personal traits in ICU is bad. But then COVID happened. So we were using these models, survival analysis models, which essentially says, given all this vital collected from lab, elsewhere, their daily condition, over time we are predicting this person's survival rate today is 70%, tomorrow 68%, then again 72%, and so on. Instead of giving a, yes, he's going to die or no, it's not a binary, right? This is always a probability. Realistic is always about probability. So we'll predict. It's a good thing. So we want to increase the chance for everybody to live, but when COVID happened, what happened? ICU number of beds are 100, COVID patients are 2,000. Now, the same model that we developed for certain purpose is now being used to deny somebody an opportunity of getting an ICU bed. Is that good or bad? It's bad, but hospitals use it. It's a very gray area. So the same model, when used for different purposes, can still be bad. So I'm bringing out these nuances of how models in the real world can be ethical or unethical and come under regulatory compliance rules based on where they are used, and it's a tightrope to walk in an industry. Finally, I want to talk about marketing campaign models. You know what marketing is, right? They will collect your age, your gender, your preferences, and then do a targeted ads to you. And it's all AI. So these people are saying, hey, you know what? We don't care. We are targeting your personal traits and marketing to you. So such models are good or bad? They are okay, I guess. I mean, it's legal, but I won't call it fully ethical, but they are legal. The reason is because if you use a marketing model, it's not going to deny you something. Some opportunity is not denied. It's only affecting your consumer behavior. So as long as it is not denying you or making a systemic exclusion of things, usage of that data is all fine, even from a regulatory perspective, even from an ethical perspective, I would say. And now let me switch over to something on the technology side here, okay? HIPAA, Health Insurance Portability Accountability Act. It's not in India, it's in US, which talks about the patient's data privacy. It doesn't talk much about processing of the data or using the data for decision making, but it's just about how much privacy can I give. Here there is no privacy, right? I mean, if you go to any hospital, people's data is lying around. It's not so in other countries. And it comes at a cost though. Other countries, the medical cost is much more, particularly because of this. So there are good and bad sides to it. So this is one thing where the data has to be private. The second area where I see the data has to be private is, let us say you are a small bank and you want forecasting models that would tell how much loan will people want 4 months from now, 5 months from now, or a ERP vendor who is using a external cloud service. Now to do all this calculation, we have to send the user's personal data onto the cloud to a third party. It's a violation of the confidentiality of the personal data and the privacy also. How do we deal with that? Now let's keep all the legal, ethical side aside. Think from a technology perspective. How would we deal with that? How would we generally deal with the data that needs confidentiality? We encrypt it, right? We encrypt it. So we have symmetric encryption, asymmetric encryption, and so on. We'll encrypt the data and send it across. Now the model, instead of training on the real data, is training on the encrypted data and using those encrypted data as a feature for predicting, some forecasting or any decision making. It will not eliminate the bias, but it will still solve the privacy problem. So one problem is solved. However, it's not so easy because once you encrypt the data, there is a lot of noise in the data. Once you have noise, if you look at any neural network, the noise multiplies, right? You add a non-linearity to it, the matrix vector multiplication, it adds up, it just blows off. So anybody has done computer vision models here? So you know about ResNet? Yeah. Why do you need ResNet where the original data is fed back after a certain time is because the original data that went through forward processing becomes so unreadable that you inject the original data. We need something similar here. But the original data has to be private, so it can't be fed. So another round of encryption. You know how asymmetric encryption is hard, right? I mean, it's 1,000 times slows down your AI training process. As such, AI training is slow. You need good GPUs, costs a fortune. On top of that, now you are imposing these new things, homomorphic encryption that encrypts slowly, bootstrap again. It's a problem. There are some more details that I think I'll skip in the interest of time. An alternative that we do is autoencoders. Heard of autoencoders, right? So autoencoders consists of an encoding part and decoding part. For a 10 feature, 100 features, we reduce it down to a latent space including maybe 5 features. We are able to capture 90% of the original data in the encoding space and just pass on that to your SaaS vendor for all the forecasting. Privacy is maintained. You also don't incur much computational costs. Also, GDPR, if you have anybody dealt with it, it's a European law that says if you are using customer data, the customer is in control of when and how a business can use their data and also when and how a business should stop using their data, to the point that saying once the consumer says his data has to not be stored by the vendor, within 30 to 45 days it has to be completely deleted from the system. This poses a big challenge that many would not even think of. I have developed a model today using my consumer data who have opted in to share their private data and developed a model, deployed it in production. Developing that model, training it, took me a lot of time, a lot of resources. Now suddenly the customer comes and says, hey, you know what, don't use my data. What am I going to do? Should I retrain? Retrain at the same time? Retrain in 30 days, 45 days? What is the cost that I'm going to incur? These are the issues that we have to grapple when we come to industry because of this responsible AI. So it's not as simple as, okay, I'm going to introduce bias, fairness. What are the logistics issues? I mean, this need more innovation, obviously, and innovation should come from academia, right? How do we deal with bias? Bias is a class-specific thing, right? Suppose you had a color, race that were used for doing some prediction. You can look at your model's true positive rate, false positive rate, correct? You all know what, the confusion matrix, right? It might have confused you, but that's why it's called confusion matrix, that it has a true positive rate, false positive rate, and so on. We have a global true positive rate and false positive rate. We take that and say what are the class specific true positive rate, false positive rate, and accordingly we can decide during our initial training with all the data, is there bias in our model? Because that's the first problem, right? I need to know if my model is going to have bias, and then I'm going to work on an optimized model. So we do that, and for example, TensorFlow comes with tools, and if anybody is doing research in this area and want to really get this biased data out of their models fast, I would suggest even with PyTorch, TensorBoard works. IBM has some nice models. TFX, which is extension from TensorFlow. Azure offers some fairness learn or something like that. These are all good things. And I guess most of you are aware of loss functions, what loss functions are in a neural network, right? You kind of decide how much unhappy you are with the final result. We can actually tweak your loss functions to handle the bias. I mean, I would say this is the best thing to do, because sometimes even after removing certain fields, the bias will be left over, and that bias can be handled using this. We could also do undersampling, oversampling, but experience shows me that that's probably not the right approach at all. Okay, we'll come to explainability and causal AI in 5 minutes and kind of wind it up. Explainability is also a part of responsible AI, because GDPR and CPRA from California, those demand that whenever my model makes some predictions, I should be able to explain it to the customer, saying why a certain decision was taken. I think some of you might have explored the generative AI, ChatGPT, how you can add explainability to ChatGPT. Similar things exist here. I'm trying to avoid the generative AI space together because others are going to talk about it. My focus is more on the hardcore models. And these are important for healthcare, finance, criminal justice system, right? I mean, you would have all seen how judges, their decisions using AI have this bias toward certain race, certain color. It has happened in the US a lot, and they are part of Stanford studies as well. What do we use for generally for explainability? I mean, the kindergarten of ML says that, okay, feature importance, right? Feature importance is also one way of explainability. You're going to do some kind of random forest or XGBoost or any boosting methods, for example. Then you get feature importance right out of the box. You don't have to do anything else. Similarly, we have Lime and SHAP. Lime is like saying, I'll probably give you an example of this Earth. Earth is round, right? But you can take a small section, it still looks like a flat thing, right? So even though our cost function is a convex or non-convex function, I can take a small area of that and say, you know what, in this limited area it's linear, let me apply the linear, and linear models are always very explainable. So that's the idea. SHAP is a classic example of how interdisciplinary things start impacting innovation within AI. The SHAP model comes from essentially the game theory, right? You know, you heard of game theory in the context of economics, how it developed. There was a movie on that as well. So there are partial dependency plots. I can go on. But another area where I would probably bring to attention of academia is graph neural networks and explainability there. It is an unsolved problem. The existing solutions are very, very inadequate, very expensive, and the answers are not satisfactory at all. GNN primarily, along with geometric learning, right, for example, gets used in drug discovery. It's a big part of the drug discovery thing, where you have 200 molecules, big molecules, right? You want to narrow it down to 10 molecules and then say, these modules are going to be used, going to be really physically tried in the laboratory, correct? So, and when we do that, we want to know why such models were selected. We just get a prediction, and if you go with it, investment in each molecule can be several $100,000. So 20 molecules, one wrong molecule suggested, the effort put into is like $1 million there. I mean, that's why pharmaceuticals have lobbies, right? They want to ascertain that their dominance remains for a while. And in autonomous AI, this is one area where practically no good research exists. In reinforcement learning, how do we do explainability? Take a autonomous car. It's driving, self-driving on the road, it hits somebody and some death occurs or something, right? It's a very risky thing. How did the computer on board the car take the decision to take a turn or hit somebody? It needs to be explained so that the next time it can be corrected. Otherwise, if you leave this reinforcement learning based models to be black boxes like they are, God save us. None of the cars will pick up. And here it comes to model-free methods, model-based methods. I don't know if anybody works on RL here, reinforcement learning. It's pretty interesting in terms of research. A lot of gaps are there. And we have tools as well, but they're not for RL. All right. Causality, I'll probably finish the causality part very fast. We all know that correlation is not causation, right? Any statistics student knows that. And ML is really statistics, linear algebra, and differential calculus with optimization. It is less about computer science. So most of the ML that we do is correlation ML. So let us say, have you heard of this example? I don't want to repeat it. Ice cream sales versus shark attacks. How many of you heard that? Nobody heard it? Okay. So this is an example out of Australia, right? People eat ice creams. So there is a data of how ice cream sales have happened over the year. And then people go to beaches, there is a data about how many shark attacks have happened. And believe it or not, there is this great correlation between number of ice cream sales that have happened and number of shark attacks that have happened. Which means I can build a ML model using my ice cream sales as the feature and the shark attacks as a predictor. I'll get 99% accuracy. But really, did ice cream sales cause it? No, it's about a confounding variable, meaning that which drives the other two. It was summer, it was a good temperature, maybe it was hot, so people ate ice cream, and maybe because it was hot, people went to the beach, and now when they are swimming, there has been a shark attack. But when you look at it, you are using really not the real variable to predict. So you are using just the correlation and not the causation. There is absolutely no cause and effect relationship between ice cream sales and shark, yet here we are developing models based on that. And causal AI is exactly about that. Let's get rid of this correlation based things, because when it comes to explainability, we want to go a little bit further, and that's about causality. Again, Simpson's paradox. If you do the calculation across all ages about how much people exercise and how much cholesterol there is, you will get a weird relation that says the more you exercise, the more cholesterol there is. That's because you have left out the confounding variable, which is age, which is the slicing thing there. You just missed out the real variable and you got this weird conclusions. That's called Simpson's paradox. So causal AI is all about not being a black box in your AI, inserting the domain knowledge. So what does inserting domain knowledge mean, let's say in the aerospace field, or like in my case, I'm doing this autonomous machine where a shuttlecock is thrown by a machine. I'm looking at the partial differential equations that create the air drag, carry it around at various speeds, right? So I could include the partial differential equation that guide the movement of a shuttlecock as part of my model. And that's where it brings me to the physics-inspired neural networks, where the regularization part in the model, we'll say lambda something, and there is a Lagrange multiplier. That's where the whole equation goes in and says how much of the physics should really drive my ML model. And in physical space, these physics models can serve as the causalities also. There are tools like DoY. I would suggest that you go and look up in GitHub. DoY, it's from Microsoft. It lets you figure out the relation, cause and effect relations by using things called interventions and counterfactual analysis. Counterfactual analysis means if A, then B, which is what you know, then you cut off their relationship and say, if not A, am I resulting in not B? Then it is counterfactual analysis. So essentially I've covered a bunch of areas that industry looks at, and for more participation from academia, because this is primarily an industry headache, and it's just not a social and a legal compulsion. I look at it as a catalyst for innovation. History tells us, just go back to 9/11 when it happened, right? The 9/11 triggered a whole bunch of innovations in terms of fintech, how the America handles their check clearing, the financial instruments. The whole thing was over. Like I was in New York at that time. So I saw through that changes when the legal things came, the compliance requirements came. It drove a whole new of products, academia research, interdisciplinary things coming out of that. So applied research from academia in collaboration with industry that helps solve an existing problem in industry would be what generates some revenue also through the collaborations. And these new tools can also come through open source collaboration. We do a lot of contribution in our company to open source tools. Obvious, we have our vested interest, but our vested interest is, okay, we want to establish ourselves as an authority in the field, but so do you, right? I mean, academia also wants that credit. So participate, contribute, let us all contribute our part to the responsible AI being mainstream than being fringe. Thank you.
Thank you, sir, for giving a wonderful and enlightened talk on this responsible AI on this conference. And I hope the audience have get the benefited from this talk. Now the stage is open for the audience. Have a few questions for discussions.
Yes, plus because ISO 2001 is mainly for organizations who have started working with AI, so we are talking about the responsible AI.
I guess at India's legal standpoint, from my what little knowledge I have, we are not even at the point of privacy. So it's a three-stage process, right? First you have to ensure privacy and confidentiality. Then you say, okay, the data is encrypted in motion. Then you go to the processing part of it. Then removal of the bias in the decision making. With that DP Act of 2023, in India is probably still at the stage of privacy. And I would even say that it's a subset of HIPAA regulations. Okay. It's very abysmal, but that's what it is.
Okay, sorry. So you obviously mentioned about the DPA Act. So am I right in thinking, obviously, after the implementation of the GDPR, India has come up with a GDPR-inspired bill, and was it
Yes, it is still not passed. I think it's called Digital India Act of 2023, and they said they'll pass in 2024 after the election. I don't think it's still passed, not even tabled in Parliament.
So it has to go through
Yes,
Parliament
yes.
process until that is passed.
Yeah.
Okay, thank you so much.
Excuse me. I have a question. What I see is, say, I'm from hardware industry. AI needs to be developed using mainly fields use cases. I recently came across one example. Our company develops motor controls. And motor controls, we already have certain set of, say, errors what we face in the field, and solution what user himself can do, and has to solve it. Recently I also represented one training by a microcontroller supplier who is developing AI tools or machine learning into their control boards. But I see the AI what is developed there is far lagging and non-realistic. They are far from what is faced in field. Thank you. Thank you.
Namaste, sir. So I had this question. Like previously, you talked about how bias is there, and we have to remove bias. But for any decision making, there are few set of features that we take into consideration, which are basically kind of bias, right? Like those influence our decision. So why not consider all the features as such? Yes. So, so how do we draw the line where the bias is too much, or how do we understand that a systematic error is going on? Thank you.
Thank you, sir. Just I have a general question. You discussed about today's industrial aspect. You know, India is 70% population depends on agriculture. How your AI model is going to impact on the agriculture sector? Okay. Okay. Yes. Okay. Okay. Thank you. Thank you so much for listening. Mangalore City, I am presenting movement. Photo. Next, sir. Next session.
Professor Naveen Kumar SK chaired this session. As a token of love, I request Professor B.H. Shekhar to hand over a small token. Thank you.
We will have the presentation session. Maybe in a couple of minutes we will start.
Hello. Hello. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. It's my distinct honor to welcome you all for the paper presentation session as a part of the International Conference on Responsible AI. See, I hope the next few hours we'll all dive into the transformations that's going to happen in the next, which will change the future of AI, and we are all eager to listen to you all. So at this moment, it's my privilege to introduce the chairs of this session, Dr. Demain Anthony DeMillo, as well as Dr. Sharmila Madam, who will guide us through the forthcoming sessions. Now, let me introduce a brief introduction of Dr. Demain. So, Sir has completed his UG under Bangalore University and completed his MTech and PhD at National Institute of Technology. And his research paper was titled as a framework for the description, discovery, selection and competition of e-learning web services, which is funded by VTU. And he has 23 journal articles and 37 conference proceedings and one project under him. And Sir has served, Sir is a lifetime member of IST, that is Indian Society for Technical Education. Sir has served as BOE and BOS members for VTU, and his career started with NIT in 1999, and he later joined St. Joseph's College in the year of 2004 to 2014. Later, right now, Sir is working at Canara College, Bantwal, as a professor. I welcome you, sir. I request Swati ma'am to welcome Sir florally. Welcome you, sir. Now, I request Swati ma'am to introduce Dr. Sharmila ma'am. Thank you.
Good afternoon all. It's my pleasure to introduce another chair for today's presentation session, Dr. Sharmila Kumari. Dr. Sharmila Kumari has obtained her BE in Electronics and Communication from MCE Hassan, University of Mysore in 2000 and MTech in Computer Science and Engineering from NMAMIT NITE. She has completed her PhD in Computer Science and Technology from Bangalore University in 2012, specializing in pattern recognition, image processing, AI, ML, and embedded systems. Currently, she is serving as the Price Principal, Professor, and Head of the Department of Computer Science and Engineering at PA College of Engineering, Bangalore. Dr. Sharmila Kumari has held various roles including lecturer, assistant professor, associate professor. She has published nearly 80 research articles in reputed journals and conferences and chaired the sessions at national and international conferences and successfully executed research projects with the Moscow State University and Department of Science and Technology, DST, India. Recognized
median filtering to remove, for denoising the chest X-ray images. Once the images have been cleaned, the next step is the pre-processing, where we have resized the images to a standard size of 224 by 224, normalized it so that the pixel values fall in the range of 0 to 1, and finally we have divided the data set into train, test and validation subsets. For segmentation, we have used encoder-decoder with attention mechanism. For the encoder, in the encoder, we have used 4 encoding blocks. Each encoding block contains a number of filters that starts from 32 going on to 64, 128 and 256. In each encoding block, there are 2 convolutional layers. The first convolution layer is followed by a dropout layer having a value of 0.1. 0.1 in the first 2 encoding blocks, and in the second 2 it is 0.2. The second convolution layer is actually followed by a max pooling layer so that the spatial features could be downsampled. The downsampled feature maps are then passed on to the subsequent encoding blocks. This is the part of the encoder. For decoder, again, we have used 4 decoding blocks along with the attention mechanism, which actually helps to pinpoint the features which are actually the most dominant and give a more better accuracy. So decoder again contains 4 decoding blocks with the filter sizes of 256, 128, 64 and 32. This model has been trained for an epoch of 20. The optimizer used is Adam. Batch size has been 32. For loss, we have used binary cross entropy. Evaluation for segmentation has been done using accuracy, intersection over union and Dice coefficient, and the output for the segmentation module has been the masks, the image masks. For classification, again we have done the whole process. We have taken the input images, we have denoised it, we have pre-processed it using normalization, resizing, split the data set. For classification, we have used only the encoder, and along with the encoder, we have added 2 dense layers having a value of 128 and 256, and finally a dense layer, a fully connected layer, which is giving us the binary classification. For evaluation here, we have used accuracy, precision, recall and F1 score. Since we are having 3 different experiments, the outputs mentioned here in the diagram, we have given 3 outputs, that is for all the 3 experiments. The experimental setup contains, the model has been trained on an i7 processor model, computer system having a RAM of 16 GB, GPU 4 GB, operating system is 64-bit Windows 11. The number of target classes is actually 2, but since we have taken different classes, so 3 classes have been mentioned here: COVID-19, pneumonia and normal or healthy samples. The train and test ratio is 80:20. Dataset utilizes COVID-19 radiography dataset from Kaggle. This is the composition of the dataset. Here are the mentioned sources from where the datasets have been taken. And finally, the number of images for each classes. For pneumonia, we are having 1,345 chest X-ray images. For COVID, we are having 1,500, and for normal again 1,500. These are some of the sample X-ray images from the radiography dataset. This is the output of the segmentation module, where we are getting the first image, as you can see, is the original mask overlaid on the chest X-ray image. The second one is the predicted mask, and the third one is the GradCam that we have obtained from the model. These are the experimental results that we have got. For pneumonia versus normal, we have got an accuracy of 98.32, IOU of 93.89, and Dice coefficient of 96.85. COVID-19 versus normal, 98.79, for IOU 94.60, for Dice coefficient 97.23, and for pneumonia versus COVID-19 pneumonia, we have got an accuracy of 99.08, 96.49 IOU and 98.21 Dice coefficient. These are the segmentation results. The next part is the classification result. Here the highest accuracy that we have got is for the pneumonia versus COVID-19 pneumonia binary classification. The accuracy stands at 98.77%, precision at 98.80, recall 98.74, and F1 score at 98.76. The other 2 experiments follow. with an accuracy of 97.36 and 97.16. These are the confusion matrix that we have obtained for the 3 different experiments carried. The first one is for pneumonia versus normal. The second one is for COVID versus normal. This is the confusion matrix for pneumonia versus COVID-19 pneumonia. As we can see, out of the 276 samples belonging to pneumonia classes, we have got 271 accurately classified chest x-rays and 6 have been misdiagnosed or misclassified as COVID-19. For 292 COVID-19 samples, 291 have been accurately classified and 1 has been misclassified as pneumonia. These are the accuracy and loss curves for all the 3 experiments conducted. Here we have presented a comparative analysis of our work with some of the state-of-the-art works. As you can see, our model has achieved 98.77% accuracy. This is the classification accuracy that we have given. And compared to all the works that we have listed, it is one of the best performing models. In conclusion, we can say that we have implemented separate modules for segmentation and classification of chest x-rays to allow for independent optimization of each task. The segmentation module, although not directly influencing the classification output, plays an important role in identifying and delineating regions of interest such as lung areas. This enabled us to examine anatomical variations linked to different pulmonary conditions. The classification module, on the other hand, concentrated on the overall pattern present in the entire image to categorize cases into COVID-19, pneumonia, or normal classes. This model, this design has offered a flexible framework, making it adaptable for future advancement in segmentation and classification technique. These are some of the references that we have used in our work. Thank you. Sorry, sir. In terms of almost 1%, sir. Like, yeah, 1%, 1 point some percent.
What do you think, which phase of proposed methodology have improved that percent?
Maybe, sir, the pre-processing step. Yeah, maybe the pre-processing step, I feel. That instead of passing on the chest x-rays directly, we have actually cleaned up the images and then passed on, and then again the encoder design that we have used. Yes.
Okay, let us thank the presenter.
Thank you.
Thank you, Shazia Manan. The next presenter is paper ID 63, Ravi Narayan KS. Paper titled Auto Segmentation and Classification for Dental Caries Detection Using UNET and CNN Models from Vivekananda College of Engineering, Puttur. Over to you, sir.
Good morning to all. I'll be talking about the work on dental caries detection using segmentation and classification. Now, all of us have faced this issue of dental caries. It's a general disease that everybody has sometime in their life. Now, it is generally diagnosed by oral specialists and thus is a bit time consuming or you have to go there. Now, what is the motivation? Oral health affects everything from our food to our diet and our immune system. Everything is affected by our oral health because food is what maintains our health. So this work tries to mitigate that, like it tries to generate an automated system of diagnosis. Now here are few works that have been done which are major in the field.
The second work titled Dental Images Segmentation Using Threshold Connected Component Analysis was one of the influential work in the field. Now, our work began with collection of radiographic bite-wing images. We have collected 300 images which were clinically tested for this task. Now, why radiographic bite-wing images would be one of the questions that you might have. Radiographic bite-wing images are, first of all, easy to generate and require less technological investment. Now, here is a sample of the data collected where the cavities can be seen in the patches of white region. Now, the third image illustrates that the noise in the data. If you can see, a circular white patch which does not represent cavity is shown. These are few samples of no cavity samples. Now, the second step begins with annotation, where binary masks are generated highlighting the region of interest, basically the region of cavity. Now, a separate data set from this annotated data is generated for classification task. Now, here is the sample of the annotation, where we can see the mask highlights the region of cavity. Now, the third step begins with data augmentation. Here, the augmentation is done to improve the model performance by expanding the size of data set. Here, we have used horizontal flip and horizontal flip followed by vertical flip to ensure the model is robust against rotation and orientation. Now, we have also performed pre-processing where we have normalized and resized the image along with its corresponding mask to match the inputs of the model. Now, here is a sample of the augmentation. This is unaugmented data, basically a clinically collected and annotated data pair. Now, after horizontal flipping, this is the result, and this is the result after the horizontal flip followed by the vertical flip. Now, with this, the data is augmented to a size of 900 images. Now, our model architecture consists of a unit architecture which is combined with ResNet backbone using transfer learning techniques, and it is trained on the augmented data set of 900 images, which is split into 80:20 pair to ensure that no data leak has occurred. Now, we have a second model, which is classification model, basically a CNN model, which was trained on a separate data set of 400 images consisting of masks which were generated by the R model and which were clinically created. Now, this is the entire system that we have. We feed in the bite-wing images to the unit model, which basically segments the region of cavity and generates a mask, which is then given as an output. Along with that, the mask is fed into the CNN model for classification, and the classification results are paired with the mask and given as the entire output. Now, if I talk about the results, the unit architecture achieves a accuracy of 86% at generating mask, and the CNN model achieves accuracy of 97.62 at classification. Now, the testing, these results were done on a separate data set of 120 images which were collected separately, and we have compared the accuracy or the performance between ResNet 50 and ResNet 34 as backbone models. Now, if I talk about the results, this is the result where the test image, which was from the isolated data set, is segmented to give that mask. Now, the performance during training, if you observe this, it almost achieves a performance of 86% for accuracy, and we see the saturation of accuracy, which tells us that there is no overfitting. And for ResNet 34, we see similar trend after epochs 70 and 80 later on, we see a saturation in accuracy as well. Now, for the classification model, with the assistance of this segmentation model during the pre-processing stage of classification, we observe that the training becomes easier as the model achieves saturation in lower epochs itself. So, we have trained for 15 epochs, and we see that the saturation of accuracy near 96 or 97%. Now, in conclusion, this entire system automates process for dental caries detection using X-rays. Now, the lack of standard data sets pose a major challenge in the field for developing a deployable ML model. Now, this system also proposes an integrated system of classification wherein a segmentation model can be used as a pre-processing layer for the classification task. Now, few papers or references that I would mention which influence this work are as follows. And thank you. By methods, could you elaborate on the methods that you are talking about?
Because you compared with other existing algorithms, right?
Yes.
One place you mentioned 120 images.
Yes. So the 120 images that I spoke was the test data set, which was separate from the 300 training set images basically. So there are fundamentally there are two sets with me. 300 images which were augmented to 900 images forms the training data set, and the rest 120 images were kept isolated for the testing purposes. So the 900 images were later on split into 80:20 ratio for training and validation. Thank you.
Thank you, Ravi Narayan. The next presenter is Vanur Swami, paper ID 41. The paper titled Biometric Template Protection Through Advanced Feature Extraction and AES Encryption in Face and Iris Recognition from Mangalore University.
Good afternoon, everyone. So myself is Vanur Swami. I'm going to present my research topic is biometric template protection for protection through advanced feature extraction and AES encryption in face and iris recognition. So these are the contents: introduction, related work, methodology, and experimental setup, results and conclusion, reference. So introduction, see basically the biometric in a sense it's like a containing of physical traits. It contains face, iris, fingerprint and all. So nowadays due to technology improvement, the data has been leaked in many ways, like example in the social media. So we want to prevent from our data from the unauthorized users or data breaches and also the cyber criminals. Okay. So to prevent that, I want to use one of the encryption technique that is called as AES encryption technique to prevent our data from the data breaches. So here in the proposed methodology, I am combining two pre-trained model for to extract the features. Then that feature extracted data I am going to give to the encryption technique. Then afterwards I am going to decrypt. Then I am going for the classification. So this is the flow of my research work. So challenges. So in the single biometric trait system unimodel, so it suffers from the low recognition accuracy due to the various caused maybe the lighting condition, aging or physical changes, noise in the capturing data. So these are the drawbacks of in the unimodel. And so incorporating the more than one modality is also very difficult for the recognition. So unimodal biometric systems are less robust when faced with environmental variability, sensor errors and incomplete data. So many systems lack efficient integration of biometrics with cryptography, so leading vulnerability in data communication and storage security. So existing systems often do not adequate balance usability and security. So leaving gaps in protecting biometric data from advanced traits is a major challenge. So these are the related works. So in the proposed methodology, involves a comprehensive approach for multimodal biometric recognition by integrating face and iris data. So in that, I'm using a dataset as a IITD dataset, Delhi dataset. It contains around 1,440 images for both face and iris. So the proposed methodology includes data pre-processing, feature extraction, AES encryption and decryption, classification. So data pre-processing involves normalization and resize image into 224 into 224. So here I'm using two pre-trained models to extract the features. So VGC16 and ResNet50. So VGC16 it is basically works for the lower data set, and also it uses 15 convolution layer to extract the convolution layer. And ResNet50 is also one of the pre-trained model which is good for to extract the feature extraction, and also it contains around 50 convolution layer, and also it works in the to optimize the vanishing gradient point. I mean it solves the vanishing gradient point. So after extracting the features from both iris and face, so I'm going to combine with the help of feature level fusion. After that, I'm giving encryption mode. So in the AES encryption with a cipher block chaining, so CBC mode is used to securing biometric data, offering better security compared to simpler model like ECB and stream buffer like buffer block. So CBC mechanism, it contains 128-bit block of data is XORed with the previous cipher text block before encryption to prevent the patterns. So here CBC it uses a fixed set of block in the binary format. So then whenever it going for the next stage, so it's going to take the previous stage of data, I mean previous binary bit data, and to prevent the data, and also it provides more security for the next one. So this is the block diagram. So in that feature extraction and feature level. So here after feature level fusion, so I'm going to divide the data set into train and test with the help of 80% for train and 20% for test data. So here train data is encrypted by using AES encryption technique, and that stores in the data storage for the future purpose to making the use of classification. And test data, so test data and data storage. So from data storage I'm going to retrieve, then I'm going to retrieve data with the help of a decrypt key. Here, so encrypted data using the same key, and also decrypted data is also using same key for classification. So then after that classification, so I'm going to get whether the data is decrypted data and testing data is matched or not, I mean authenticate or not. So here AES encryption, it divides the data into training and testing data. So applies AES encryption to the training data. It converts a grayscale image into 8-bit binary format for the suitable of AES encryption. A binary data stream is created where each pixel is represented in an 8-bit binary number. So binary data is streamed into, divided into 128-bit block. So this bit block for used for the feature and also the previous data values. Then if the data is exceeds more than 128 bits, again it's going to divide multiple times, okay, unless that 8-bit block is contained. After that, it create cipher text blocks for the data privacy, and also it prevents the data from unauthorized users. Then cipher text blocks are decrypted by using the same key which is used for the encryption also. After that, so decrypted 128-bit blocks are concatenated to reconstruct the original binary stream. So this binary stream is converted back into original grayscale image format for the classification. So in the classification, so I'm using various classification algorithms like support vector machine, random forest, XGBoost, k nearest neighbor. So before classification, all the encrypted data is going to decrypted from the training data and restore into the original features. So use of this decrypted training data along with the test data, I'm going for the classification. So here I'm using the evolution metrics like accuracy, precision, recall and F1. So this is the experimental setup. So in that, I'm using ITD dataset which contains 1440 images, right? So I can't use 440 images because it is a very less. So I'm going to use for data augmentation. So it gives multiplied into 3. Okay, around 5,000 some images are generated with the data augmentation. After that, I'm using proposed methodology for two pre-trained models, AES with VGC16 and AES with ResNet. So here various algorithms in that SVM gives better result for AES VGC16 and also the AES ResNet 50. So these are the comparative analysis for proposed model with existing work. So in that AES plus ResNet 50 gives better result when compared to other other works. So conclusion, so this paper presents a secure and high performance approach for face and iris recognition utilizing pre-trained models like VG16 and ResNet 50 for effective feature extraction. So and also robust AES encryption is employed to ensure secure handling of biometric data without compromising the recognition accuracy. Classification algorithms such as SVM, random forest, k-nearest neighbor and XGBoost demonstrate the versatility with the combination of AES encryption, ResNet 50 and SVM achieving around 99.80 accuracy. So the proposed method advances biometric security and sets new benchmark for performance in future face and iris recognition system. So explore the integration for other encryption methods such as homomorphic encryption or quantum resistant cryptography for enhancing the data security in future work. So these are the reference. Thank you. Yeah. No, feature level, there is a technique. So we have levels of technique to merge, right? So in that I'm using a feature level. So there are like decision level, score level and other levels also there. So in that I'm using feature level. After extracting the feature, so that feature is used for concatenation. See here before giving to the feature for AES encryption, I'm using data pre-processing, right? In that I'm reducing the noise. So in that case, there is no like a similar kind of values for the features. Okay, it should be avoided. Security, ma'am. So actually it is in the two phases, ma'am. So in the first phase is that in the training data set, after like trained data set has to be encrypted and stored in the data storage. So that after in the second phase, with the help of a testing data set, I'm going to match with the decrypted data which is present in the data storage.
So you are securing the training data so that
yeah.
It will not be misused.
Yeah.
During experimentation, I see AES with the ResNet 50 experiment. Have you tried just with the ResNet and tested what is the accuracy better?
Yeah, sir, I tested, but it gives very less accuracy when compared to other.
But that data is not there. Without encryption, what is the model on that data?
Actually, I worked in the another paper, sir, like by using only ResNet and VGC16.
Because there only you can say the role of encryption, whether it has enhanced the even
in one of my paper I used both VG16 and ResNet for the single modality for the data recognition. So in that I got similar kind of result. I mean approximately on 99.
Then I
But,
think there is no
but here is the
only with respect to safeguarding the data.
yeah.